Hello, I am Mexams, and in this video, I will take you through logarithms, how to solve logarithmic questions and logarithmic equations. Okay, so let's start. Right, so there are some basic definitions that you are supposed to know. Okay, so the basic definition of logarithm is that if I have um, a certain variable, let's say x, which is given as a to the power n, then the logarithm of this x to this base a is the power. Okay, so the definition of logarithm is saying that if I have this x equals a to the power n, then logarithm of this x to the same base here is equal to the power n. Okay, hence if I have logarithm of x base a equals this, then I can rewrite the whole of this as x equals a to the power n. So in other words, this x equals this base raising this power. Okay, so keep this in mind because we will use it. Properties of logarithm: we don't have zero or negative numbers log. Okay, so in other words, we don't have logarithm of zero and a negative number. Okay, so that is one property you should know. You don't have any logarithm of zero or a negative number. Then the logarithm of b to the base b, or logarithm of any number to the same base. Here, the number here should be the same as this, is equal to 1. Okay, log b to the base b is 1. If here is, let's say, a and this is a, is 1. If here is 100 and this is also 100, it is 1. The property is saying that if I have the logarithm of a number or any variable to the same base of that number, then you have 1. Now, if I have logarithm of 1 to the base b is equal to 0, this one will prove it later. You can use this idea to prove it. Okay, this is true. Okay, now if I have logarithm of two variables multiplying to a certain base b, that is logarithm of the expressions x times y to the base b, then I can rewrite this as logarithm of x base b plus logarithm of y base b. But look, this will work. The other way will work. Like if I have logarithm of x base b plus logarithm of y base b, I can write it also as this. But there is no way you can write logarithm of um, the bracket x plus y as something like that. I will show you what I'm trying to say. Okay, all right, so let's continue. Logarithm of the fraction x over y all to the base b is the same as logarithm of the first one, the numerator, that is x base b, minus the logarithm of the denominator y base b. Hope this is okay. Now if I have logarithm of x to the certain power r base b, then this is the same as writing this power r times logarithm of x base b. That is why we are interested in logarithm, because logarithm can actually make an exponential function linear. Like this, there was an exponent here, but because of this logarithm, it will bring the exponent to the other side. Okay, so it becomes r logarithm of x base b. All these we will prove them later, but we need them to solve the questions that are coming. Okay, if I have a certain base b raising to the power x base b, look at this. The base here is b and the power here is x logarithm of x base b. If this base and the base for the logarithm at the power is the same, then the whole of this expression is the same as writing only this side, the x. I hope this is okay. If I have b to the power logarithm of x base b, then this is equal to x, because the base here, the number here b, is the same as the base of the power which has the logarithm of x base b. Okay, so all these properties, write them down, or you can copy them, or you can get them in your mind as we work through the examples. Then you record them. So the first question is simplify the expression logarithm of 3 base 2 minus logarithm of 24 base 2. So here we have same base, right? So what do? Make sure that if you can apply the rules or the properties that with it, all these properties, you can apply all these, you can apply this straight and see, or you can try to simplify to get basic things. Okay, let's continue. Solution. This from, if you can recall from this property, like I said, if I you have this, you can rewrite this back as this. If I have 0, I can say that 0 is the same as logarithm of 1 to a certain base that I'm interested in. Okay, if I have 1, like like I said, all these aspects, you can rewrite them back as that. Okay, so if I have logarithm of x minus logarithm of y all to the base bb, then I can say that the whole of this can be rewritten as what? X logarithm of b of the fraction x over y. So we are using same idea here, that if I have logarithm of this, then I can rewrite it as, because this is giving me this, okay, from the properties. All right. Now, 3 will goes here 1, and 3 will goes into 24, 8. You can even point this on a calculator, 3 over 28, and it will give you what? 1 over 8. So the whole of this is the same as logarithm of 1 over 8 all to the base 2. Now, in this case, I can rewrite this back as what we knew. Okay, you can write this back as what we knew. I hope this is clear. I can change this whole thing. This thing is the same as that we know, but this fraction from the properties of logarithm, I can change it like that. Okay, I just want to write something. I don't want to cause any confusion here. I could have done something here to say that from indices, this logarithm is the same as 2 to the power negative 3. All right. I've done introduction to indices and also solved some examples on exponential equations, and you'll get to know that if I have 1 over this is the same as 1 over 2 to the power 3, and this will give me what? 2 to the power negative 3, which will be easier, but I want to use logarithm to solve this. Now, this thing here is the same as logarithm of what? 2 to the power 0. The reason why we are saying that logarithm of any number to the 1 to any base is 0, we are proving it through this sentence or through these examples. Okay, this 8 can also be written as what? 2 to the power 3. So it becomes logarithm of 2 to the power 3 or to the all base or 2. And this side, from indices, 1 is the same as 2 to the power 0. Now, you can 0 times logarithm of 2 base 2 minus 3 times logarithm of 2 base 2 from the properties that we did. Okay, I hope you remember that property that we said logarithm of x to the power r to the base b is the same as r logarithm of x to the base b. So the same thing here. Okay, now 0 times this is what? 0. Now we said if you have logarithm of b to the base b, they are the same, then it will give you 1. So here will give me 1, it becomes 3 times 1, which will give me 3. So this is negative 3. So from here, like I said, in other words, you can also write this as what? 2 to the power negative 3, and the negative 3 will multiply logarithm of 2 base 2, and that will give me negative 3 straight away. But if you understand, like I said, or if you want to do this is the same as that, and this is also can be written as what? Logarithm of 3 base 2 minus logarithm of this, and this is multiplication, so I use a multiplication rule, and this becomes logarithm of 8 base 2 plus logarithm of what? 3 base 2. Mind you, there is a subtraction sign here affecting all of them, and this will affect all of these. Okay, but I know that this and this are the same, so it's logarithm of 3 base 2 minus logarithm of 3 base 2. This will cancel this, and I'll be left with this. Okay, and this side, 8 can be written as 2 to the power 3, so it becomes negative log 2 to the power 3 base 2, and this will give me what? Negative 3. So whichever way we want, you can go, and then your answer will be correct. Okay, all right, so let's look at a more complex one. If I have an expression here, I'm to simplify this expression. Okay, the expression logarithm of a squared base a minus 4 logarithm of what? 1 over a or base a. Okay, this is very simple, right? Let's look at the solution. The whole of this expression can be written as what? These two will come here because of the property that we know, that if I have, I hope you remember, logarithm of something to the power r base something, I can write the power in front of the logarithm. Then I write logarithm of the base to the base given. Okay, so this becomes this, and then this side from indices we know 1 over a is the same as a to the power negative 1 from exponent. I've done a video on indices, so you can go and check. Okay, now in this case, this logarithm is a base a, the same numbers here, so it becomes what, 1. So it becomes 2 times 1, which will give me 2, and then minus, then this will come here. Okay, this power will come here from the properties of indices. Come minus 4 into bracket negative 1 logarithm of a base a. Okay, and then a base a, what do you think will give us? This will give me 1, so it becomes 2. Negative 4 times negative 1 becomes positive 4, so 2 plus 4, which becomes what, 6. All right, so I hope you understood this, right? You can go through it step by step and you would understand. Okay, so let's continue. Question 3. Given that x equals 2 to the power p and y equals 4 to the power q, simplify the logarithm of s cubed y all base 2 in terms of p and q. Okay, so look at it clearly. We've been given that these are the representations of what, x and y in terms of p and q. Okay, so if that is the case, then I try to, all that I have to do is that I'm given an expression to simplify, like logarithm of x to the power 3 y base 2. So all that I have to do is just find x to the power 3, because s is given as 2 to the power p, and s to the power 3, I just have to put 2 to the power 3 in place of x, and that will give me this. Okay, and from indices, you said from the power rule, this becomes a 2 to the power 3p. Okay, now y to the power, y is just 4 to the power q, and this in terms of 2, I can rewrite this in terms of 2. 4 is the same as what, 2 squared, and so here is 4 to the power q. So if 4 is the same as 2 squared, then it becomes 2 squared all to the power q, and then this becomes 2 to the power 2q. Okay, now we are supposed to do this, but I want to bring everything out, simplify them first before we come and put them here. Okay, now s cubed times y will give me what? Now I do s cubed times y. S cubed is this, and y is also this. So I could just put them together. And then from indices, the product rule, we say if the bases are the same, take one base and you add the powers. Okay, and you add them. So it means s cubed y, this side, or only this side, is equal to 2 to the power 3p plus 2q. Then I can say that hence the logarithm of this s cubed y base 2 is the same as logarithm of what, 2 to the power 3p plus 2q or base 2. I hope this is correct, right? Now this, from logarithm, the power can come in front. When the power is 3p plus 2q, I hope you can see the whole of this. If it comes in front, then I'll be left with what, logarithm of 2 base 2. Logarithm of 2 base 2 is what, 1. So everything will be what, 3p plus 2q. So we've been able to simplify this expression in terms of p and q. And I hope you understood this, right? Okay, let's continue. Given that y equals log x base 2, write each of the following expressions in terms of y. Okay, so I've been given log of s squared base 2. I'll be given log of 8s squared base 2. Okay, now the solution is, if I have log of s squared base 2, from logarithm, what can I do? We see the power here can come in front. Okay, so this becomes 2 logarithm of x base 2. And what is logarithm of x base 2 given in the question? Is y, right? So but y is equal to logarithm of x base 2. So I just replace, in terms of x base 2, logarithm of x base 2, I replace it by what, y. Then it becomes 2y, because we had 2 times that and it becomes 2y. So we've been able to express this first one in terms of y. Now logarithm of 8s squared base 2 is the same as saying logarithm of 8 this they are just multiplying 8 times s squared. So from the product root of logarithm, if they are multiplying, I can write it them as what? Logarithm of the first one, that is 8 base 2, or with the same base, and plus logarithm of the second one, base 2. Okay. Now, but we know that log 8 base 2 is the same as log of 2 to the power 3 base 2. The reason why we are trying to make sure that we get the same base here is whenever you are given logarithm to simplify, try to make sure or rewrite your number in terms of the base. Okay. So in other words, I'm trying to rewrite this 8 in terms of this base 2. So 8 in terms of 2, or an exponent of 2, is the same as 2 to the power 3. All right. And that will give me 3, because like with it here, this will just be 3 log 2 base 2, and log 2 base 2 is what? 1. So I'll be left with what? 3. All right. So also logarithm of this one, we've done it already. This one, that is 2 log x base 2, and that when we went through it, we had what? 2y. And so logarithm of x squared base 2 is 2y. So I come and put them here. Okay. Wherever I see log h base 2, I know log h base 2 is giving me what? 3. This is also giving me 2y. So I put them into this equation. I'll get 3 plus 2y. So in other words, we've been able to simplify this expression as what? Y. Okay. Now, given that y equals 4 times 10 to the power 2x, express x in terms of y, given an exact simplified answer in terms of logarithm to the base 10. So you're supposed to express x in terms of y, and then we are supposed to use logarithm to the base of 10 to simplify whatever we will get. Okay. So now the solution is given us, if y is this, okay, then this implies that logarithm of y, I take logarithm of this side base 10. They are saying that we should use base 10. So we will take logarithm of both sides to the base 10. Okay. And doing that, logarithm of y base 10 equals logarithm of the whole of this expression, 4 times 10 to the power 2x base 10. And we know that from the product rule of logarithm, I can expand this by saying that logarithm of base 10 equals logarithm of 4 base 10 plus logarithm of 10 to the power 2x base 10. Okay. I hope this is correct, right? Just mind you, you should always use the properties of logarithm in solving logarithm questions. Okay. All right. Log y, mind you are trying to make x the subject. You are saying that we should express x in terms of y. So in other words, you are making x the subject. Okay. So log y base 10 minus log 4 base 10. Someone asks, why are we sending this to the other side? You want to make sure that x is standing alone. Okay. And then when x stand alone, we can make x the subject. Okay. So this is equal to logarithm of 10 to the power 2x base 10. Okay. So in that case, from the properties of logarithm, I hope you remember, we said if you have subtraction like this, logarithm of y base 10 minus logarithm of 4 base 10. Once they have the same base, then I can write them as odd, a fractional logarithm. Okay. So it becomes logarithm of y over 4 all base 10. And this is equal to, here the power rule of logarithm, you take 2s to the front. Okay. Then become logarithm of 10 base 10. Alright. Now, logarithm of 10 base 10 is what? Is 2. If this becomes 1, so this will give me 2. So this becomes 2x is equal to the whole of this. So, or the whole of this is equal to 2x. So I can rewrite it in the other way around. Okay. That. Now, if I want to find x, what do? I divide both sides by 2. Okay. So if I divide here by 2, I'll get x. And this will be equal to what? If I divide this by 2, it becomes the whole of this over 2. In other words, I can rewrite this as what? 1 over 2. So it becomes 1 over 2 times logarithm of y over 4. Okay. So in terms of y, I've been able to find x. So I just made x the subject from the whole of this. I hope this is cool, right? So let's continue. Solve for x in the logarithmic equation. Log x base a plus log of the expression x minus 3 base a equals log of 10 base a. Here, you should take note of here. This is not like the fractional logarithmic property, because here this is x minus 3 all to the base a. This is not like logarithm of x base a minus logarithm of 3 base a. If they were standing alone and then the separating power, or sorry, the separating operator is, let's say, negative, that is when I could have applied what we call the fractional property. Okay, now same thing happens to the product property. If the plus is here, if let's say here was plus and then the whole of the expression was um, having a base of a, logarithm of the whole of this expression, and here is, let's say, plus, you can't use the multiplication property. Okay, just make sure that if, let's say, this here, there is a plus here, so I can use the multiplication property because I have a log of this term base a log of this term base a. I hope you understand. So make sure that before you use them, the log should happen at different terms, or the log should be operating on different terms. Okay, so solution, if I have this and it's equal to that, then since this is a plus and this log is to the base a and this log is to the base a, then I can multiply this and this side. Okay, so this implies that logarithm of what, x times, this x times this expression equals logarithm of what, 10 base all to the base a, right? Now, from exponential equations, if this is true, then we are saying that we can write the whole of this as this. Why? Because from exponential equation, if I have a to the power certain expression and it's equal to a to the power certain expressions, then I can equate the power since the bases are the same. So we can equate this and this. Same way, if I have this, then I can take these to a certain base, this to a certain base, and it's equal to this to a certain base. So I can just, in other words, this is what I want to say. I want to say that I can take the whole of this, can take a certain base and raise it to the power this. I can take the same base and raise it to the power this, like I did here. So I took a to the power what, logarithm of this side, and I took a to the power logarithm of this side. Now recall from what, exponential equation. So I've done a video on that, solving plenty questions on exponential equation. So if you don't understand this, you can go back and check upon that. Okay, all right. So this, what property can you see from logarithm here? What property can you see? We said if I have a to the power something and the base here and the base here are the same from logarithm, then the whole of this whole thing is the same as this. And if I have the same base here and the same base here, then the whole of this is out and I will take what, only 10. So recall from, if I have this is equal to that, so comparing this and that, you can see that the base here is the same as this, likewise this one, and we said the whole of this was equal to x, so it means the whole of this side is equal to x times x minus 3, and the whole of this side is equal to what, 10. Now I expand and I'll get something like this. This implies is that what I have this, I take 10 to this side and it becomes what, negative 10, right? Or equals 0. So I use what we call quadratic factorization and then solve this one. Okay, using quadratic, you can even point this on a calculator. Just press mode 5 and you press 3, okay, on your calculator, and they will ask you to punch the coefficients of these. Just coefficient, the a coefficient points 1, the b points negative 3, the c points negative 10, and it will solve this for you. But let's walk through it step by step. Okay, solving quadratic equation, we said you just multiply the coefficient of this side by this negative 10 and you get negative 10. So you find two factors of negative 10 that when you multiply you get negative 10, but when you add you get negative 3 here, and that is negative 5 and 2. Okay, negative 5 times 2, you get negative 10. But when you add, you get negative 3. So you just split this into those factors. Okay. And in so doing, I can factorize this side, factor 2 out from this side, and it becomes, sorry, I factor x out from this side, it becomes x plus 2. Then minus 5 out, it becomes s plus 2. Because if I expand this, I'll get this back. Okay, equals 0. Now, I just factor, this is s plus 2, s plus 2. So I have to factor s plus 2 out from both side. Okay. Then if I factor s plus 2 out, what will be left here? It will be left what? X. Here will be left with minus 5. And so this implies that x plus 2 equals 0 or x minus 5 equals 0. And this x equals what? Negative 2 or x equals 5. Now, to know that this is actually which s satisfy the equation, you have to test for all of them. If x equals to negative 2, put negative 2 here. You can't log of negative 2 base a. And we said we don't have logarithm of negative 2, so it means negative 2 won't work. Then we have to choose x equals what? 5. So that's the solution for this question. Okay. If you have any question, you can type it in the comment section, and then when I see, I would answer you. Okay. Now, given that p equals logarithm of 4 base a and k equals logarithm of 5 base a, express each of the following in terms of p and q. Your final answer should not contain any logarithm. Okay, so this is a restricted statement here. Okay. Now I have logarithm of 100 base a. I want to split it in terms of 4 and 5 base a base a. Alright, so logarithm of 100 can be written as what? 25 times 4. Okay, 25 times 4 will give me 100. So this is equal logarithm of the expression 25 times 4 or base a, and this will give me what? This is a multiplication rule. So logarithm of 25 base a plus logarithm of what? 4 base a. So I hope this is okay. Now this 25 is the same as what? 5 squared. Okay, we want to make sure that we simplify this to the extent that we will get logarithm of 5 in this. Here is okay for us because we have logarithm of 4 that is here, and this becomes logarithm of 5 squared base a plus logarithm of what? 4 base a. And this from logarithm property, the power rule or the power property, we are saying that the 2 can come in front here and becomes 2 logarithm of 5 base a plus logarithm of 4. And then from here, just go and see. Logarithm of 5 base a is what? Q. Logarithm of 4 base a is what? P. So we put wherever we see logarithm of 5 base a, logarithm of 4 base a, we put P and Q in it like that. Okay, so this becomes 2Q plus P. So we've been able to simplify this in terms of what? P and Q. I hope this is okay, right? Okay, then let's look at the second one. Logarithm of 0.4 base a. Wow, this is not easy, right? Okay, but we know some fractions and decimals. Okay, so you can rewrite this as what? 4 over 10. This 4 over 10 is the same as 0.4 from the basic fractions that we did from basic school, right? Now I can rewrite this as what? 2 over 5. Hmm? And from the fractional property of logarithm, this becomes what? Logarithm of 2 minus logarithm of 5, or base a base a. Okay, take them to the same basis. Now we know this logarithm of 5 base a, we know is what? Q. This one we know, we are cool, but we don't know this one. But let's see, 2 and 4, what relation do they have? We know that the square root of 4 will give me what? 2. Okay, or 2 square will give me 4. But if I put 2 square here, it means I've changed things here. But if I put the square root of 4, it's the same as 2. Nothing has changed. Okay, then minus logarithm of 5 base a, right? In that case, square root, we did said an introduction to said. And in that video, we said that the square root of any number is the same as the number to the power half, right? So this is the same as saying 4 to the power half base a. That is logarithm of 4 to the power half base a minus logarithm of 5 base a. In that case, the power property of logarithm will tell us that we should put the half the power in front of the logarithm, so it becomes half logarithm of 4 base a minus logarithm of 5 base a. Now we are good to go because we know logarithm of 4 base a is what p, logarithm of 5 base a is what q. So we put them in, and this become half p minus q. All right. So thank you, and then subscribe to my channel if you haven't. And if you don't understand the way I used the exponential equation and exponents and then the indices and this, kindly go and watch the exponential equations examples that I did. Share and also comment for more videos, okay?